Hello everyone, my name is Anestis Kyvranoglou and I'm currently CTO at Trainme.club. On this course we're going to talk about unit testing, and although the examples are in C#, the principles apply to almost any other language because you're going to find similar libraries and mocking frameworks in your language of preference. Before we proceed, I'm going to say a few words about me. I started my career as a freelancer. I mainly developed code in .NET and full stack in JavaScript frameworks. Later on, I moved on my career as a CTO at TrackTrack.de. It was a German startup, and I led the team working on those two platforms, and I wrote all the backend code, which was in .NET 4.5. Later on, I jumped into Stoichman.gr as a senior software engineer, and later on as a tech lead. My team was working on the main website that currently runs in production for Stoichman.gr. And the next step in my career was to lead the teams at TeamViewer, working for the TeamViewer meeting product. It was teams working for platforms: iOS, Android, Windows, and macOS. Didn't write any code on this role. And currently I'm at Trainme.club for 1.5 years, and the code I write is mostly for prototyping React Native applications and React.js in TypeScript, and also we're using TensorFlow for machine learning. So, what is unit testing? I'm not gonna jump into much theory about that. I'm gonna say that it's just code that tests your code. I'm trying to be practical on this course. And what does code do best? Doing things fast and automatically, so you just don't get to do them yourself. And that leads to stable and maintainable software. That doesn't mean your software won't break. It will break, but you're gonna learn about it very fast, and it won't cause damage in production. Your colleagues will thank you, and for me that's the biggest benefit. Most of the times when you inherit legacy code from somebody else, the first 2 days it's just chaos. You're trying to figure out what the code does. It is some legacy business logic 10 years ago. You have no idea about it, and you are just very careful not to break anything. So if there are unit tests, it's much easier to extend the functionality of that code. You can just add your extended functionality, run the tests of the previous dev, and see if you didn't break anything. If you didn't break anything, everything is fine, you can move on. Your weekends will be more peaceful, because if you write unit tests for your own code, then if somebody else comes in and inherits that code, if he does break anything, he's gonna learn it fast, and you won't be the one that's gonna jump into the fire later on. Also, less bugs equals more time doing creative things. Who doesn't love developing new code instead of solving bugs? And finally, you get your chance to level up your code. And why is that? Unit tests require testable code, and in order to have testable code, you need to follow some specific best practices. So you just end up having better code. So why not then? Why doesn't everybody have like 100% code coverage? In most companies I have seen, the code coverage it's pretty low. So there are reasons not to have unit tests. First of all, testing is not cheap. There are misunderstandings that just writing a unit test, it doesn't take much time. It's not anything. Just write a unit test. No, it's not that simple. Unit tests require testable code, and this is the hard part. Testable code, it is hard and takes time. And also, this is the main part of this course. We're gonna see it in practice on the next examples. Also, unit tests require maintenance, because it's also code. If you change the requirements, you need to go back and change the tests. If you have many tests in much code, you need much more things to change. Also, unit tests are easy to get wrong. So there are cases you can just end up testing a library that's already being tested, or testing the wrong stuff, or testing things wrong. So you need to get a good grasp of what does have meaning to unit test before writing your first unit test. Also, there is the risk of work duplication. In chance of requirement change, and that does happen a lot, especially in startups, if you end up throwing your code into the trash, if you spend like extra effort writing unit tests, those things also gonna end up in the trash. So, and in some situations, this effort is never gonna pay off. Which are those situations I'm gonna explain on the next slide, but there are situations that doesn't worth writing unit tests. And finally, the delay time to market. So this is the main reason and also excuse for many not to write unit tests. Of course, product owners push for early deadlines. You need to release fast, you need to evaluate your product fast. So we don't write unit tests, we didn't have the time. And this is wrong. This is an excuse, because you can write your code, release it, test manually in the first catch. You have your code running in production, so you're okay with that, and you can come back later on and write your unit test. So, time to look at the code. The function we're gonna test is the buy stock function. And what it does, it checks for invalid parameters. In case of invalid parameters part, it's gonna throw an exception. It gets the user's balance and to see if the user has the required amount of money to do the purchase. It adds the tax, and then if everything is okay, it withdraws the money from the user's balance, and also reserve the stocks. If I try to test this function manually, the regular procedure was to run the website, log in with a customer. That implies that I have an account on the website on the development stage at least. I need an account with some kind of balance. I need to purchase a stock, and I see that everything is working right. Yeah, I tested like one occasion of the many. Like I have different taxations between different countries depending on the user. So I need to test for many users, many countries. I have different percentage of taxes being removed from the user depending on the country and the amount being placed. So if I want to test all the functionality, I need to have many different accounts with already set balances inside the system. Every time I run this test, I will affect the database, and it's gonna get very complicated and not end up very well in the end. So it pretty much ends in some situation impossible to test manually all this kind of functionality. So of course the suggested way is go and run unit tests. On the .NET framework, unit tests are just an extra library project on technically it is a library project on your solution, and this is we're gonna use the XUnit testing framework on this course. So I'm gonna add an XUnit testing framework. By convention, the testing projects have the same name as my main project, followed by tests. So it's just stock site tests. And yeah, we're using .NET 6, and I have created my unit test function. So on this course, I'm not gonna stick too much explaining the unit testing framework. I get you might find online courses explaining the frameworks. I'm gonna stick mostly into testing the practical stuff of your code. So I'm gonna come here and write the code for testing this function we have seen before. By convention, we need to add it is a convention to add your testing code with the same structure as your actual code. So on the website we have the stock site followed by the business logic folder and the stock by folder, which contains our function to test. So I'm gonna follow the same structure. Business logic, and I'm gonna add a new folder which is the stock by, and also following the same convention, the tests of a specific class need to have the same class name with their code being tested. So since we're gonna first test the stock purchase handler and the buy stock function, I'm gonna add a new class named stock purchase handler and tests. This is the convention, the same name of the class followed by tests. And of course all tests need to be public for the framework to detect them. So it's time to add our first test, and each unit test is a function on XUnit. So we're gonna say a public void. Function names should be descriptive of the functionality being tested, and so we're gonna say that buy stock, or better purchase stock with enough money should pass. And this is a convention on naming test functions. It is kind of a templating that doing something depending on orientation should pass or fail. Got a typo here. And on XUnit, in order to mark a function as a test, we need to say that this is a fact. So this signals that this actual function is a unit test and allows the test explorer to locate this test. Now, since we're gonna test code from the stock side, we need to add it as a reference to the test projects. So we're gonna add the project reference, we're gonna add the stock site, and we now have access to the code of our website. So getting access to our site, we're gonna test the stock purchase handler function and class. So we're gonna instantiate it. Purchase handler equals new purchase handler, and we need to test the purchase stock function. So purchase handler dot buy stock, and we need to enter the amount, let's say, of the stock, how much money of the stock we're gonna buy, the stock ID, and the username. And this is where the problems start. So okay, it's easy to decide on an amount, but which stock ID and which username? I need to have access to the stock IDs, find a specific one, also have access to the accounts, but let's try that. So we come here and let's say let's declare those variables. This is the arrange phase of our test. So forgot to mention, this is a pattern, the arranged act and assert convention, many call them a pattern also. And all unit tests have three phases: the arrange, where I set up the needed classes, the needed parameters that the test is gonna run, the act phase where the actual test is run, and the assert phase where I assert something and decide if the test is correct, if the code executed well or not, if it failed. So on the arrange phase, I instantiate my class to test, and I need to run the function on the act stage. Before I do that, I need to instantiate the parameters. So we have the amount. Let's say the amount is 100, you call it dollars or euros or whatever. We have the string username. I know that there is a user on the database called with my email, so it's gmail.com. Let's say I also assume that I know some hard-coded stock ID which exists on the system, and it's like the stock ID of 1. Okay, there should be a stock ID with name 1, with an ID of 1, and I will try and run the code with these parameters. So this is the amount, the stock ID, and the username. Okay, thank you, intelligence. And then what does say is that my function runs okay or not. So this is the assert phase, and the buy stock function returns a result of boolean if the function ran correctly or not, right? So not run correctly if it was successful or not. So to sum it up, I'm gonna purchase a stock that for 100 euros, and with the username of my current account and the stock ID of 1. And if everything runs okay, I should assert that equals or not equals, it is true that the result is true. Okay, so what happens on this test? If the result is true, it will succeed. If it's false, it will fail. Let's try and run it. Running the test, I will see that it needs to build a little bit. Other executions will be much faster, we're gonna see it, and I see that it fails because it was expected true and we got an actual false. Why is that? Well, I don't know, seriously I don't know what's gonna happen inside that. What balance does the user have? Does it have the 100 euros on his account or not? Let's try and reduce the amount of money and run again. It says, I'm going to run it again. Yeah, it's true, it's success. So let's try one other amount, let's say 80. I think you start to see what's the problem here. My test is purely dependent on the state of the system. So if I happen to have a user with that name and this amount of money, it runs. And even if that's the case, okay, I make sure that I have a database with this same amount of money, and to make sure that my test has everything it wants to run on the database in terms of user money and so on. So I try to run the same test 4 times, right? Logically, it's the same test, it should have the same result. That's not the case. Why does that happen? So all those tests run in parallel, and even if I have the same, let's say, the required setup on my database for this test, there gonna come other tests and will affect that state. So the first two tests run okay, the other two don't find the required balance because it has been removed from the previous test and they fail. I need to stabilize that. So I need to have always a predictive state for my system to always run at the same situation in order to actually test if the code is successful or not. So this is what we're gonna do on this course for the following time. I will keep the function as it is right now, and here comes the part of the testable code. So what I mean by testable code, if I go and pick inside my handle functionality, I see that there are dependencies in system resources, which is the user data provider. It is a database connected service. It is the tax calculator and many other services which depend on system resources. And I need to have predictable results from these functions. So the user data provider needs always to return a balance that I know what is this balance, and I will test depending on that. And now it's time to talk about testable code. And one of the, let's say, main aspects of testable code is dependency injection. What is the idea? I inject my service as a dependency, so the user data provider will be injected as a dependency. Let's say we have on my class the user data provider, and in most situations dependency injection works from the constructor. So I'm gonna add the construction function which accepts the service. I'm okay to remove that right now because this service right now is being injected by the function instantiated this class. And how I can take benefit of that? Let's try and build the code. It's gonna fail at first because I have refactored my code and I need to update the required functions. Let's say here I have this the stock purchase handler and the user provider. Now user data provider is a dependency of the stock purchase handler, so I pass this as a parameter on the handler. Okay, my website will build right now, and I also need to update this part of the code on the tests. Small highlight here, this comes the point that I need to say that unit tests require also maintenance. So I need over here a user data provider, and we have a problem. So it says that it's inaccessible, the constructor is inaccessible to its protection level. And if we go inside of that, we'll see that this is an internal class and we can instantiate it in a library outside of our website. And what do we do? Now this is where interfaces come into play. So actual instances of our objects are heavy. They have some instantiation logic, they have also dependencies, while interfaces are lighter, so they are easier to let's say mock and pass around. And by meaning mock, this is the main part of the course, and we're gonna explain it. But first let's create our interface. So the user data provider, it's easy to extract the interface from that, and it's gonna be the user data provider. So if we see at that, it's much lighter. Now it's very easy to create an object like that and pass it around as a dependency and control it. And by mean And what I mean by controlling it, we're gonna say right now. We're gonna control its behavior. We're gonna say every time the system requires a balance, I want you to return the same amount of money every time, whatever the situation is. And how we're gonna do it? Let's get back here. Let's update also the class types. So now we don't have dependency on the heavy object, on the specific object. We just have the dependency on the interface. So every time it just pass around an object on this purchase handler with that interface, it's happy to work with. I'm returning back to my function, and I say that I now need to, let's say, instantiate the interface. And of course we can do that. You can't have instances of an interface. We need an instance of the class that implements that interface. And this is the part where mock-Q comes into play. And if my installations were correct, I can import it in my using statements. So this is mock-Q. And what mock does? It is a mocking framework that can easily generate objects that will comply to any interface I want. So right now it's very easy to just say new mock of the user data provider, user data provider, and I have a mock of this class. And what mock does is creating with a new mock call, it creates the mock, let's say, object, and it's a configurable object. I can configure it to return specific amounts of money for these specific functions, or behave however I want to. And when I'm done with the configuration, and I can just say the user data provider dot object. So this is the actual object being generated when I'm finished with configuring. If everything is okay, right now the project should build, and now my function has the stock purchase handler runs with my custom dependency, which is mocked. And let's see the biggest benefit of that. So I say that I can configure my mock object. So with mock-Q I can say setup, and I can say that my mock, the get balance function of my mock, when called with any parameter as a username. So you can see that the get balance requires a parameter. I'm gonna define to the mocking framework that whatever it is the username, and the syntax for that is it is any type of string, and finally returns 100. So what did I manage here? If I try to debug my code right now and come over here, I will see that every time the function is run without dependency, the get balance of that service will be 100, exactly what I defined previously. If I see here, it's 100. So I'm now controlling the behavior of the dependencies. And what I want to end is that all the dependencies will be behaving in the same way, which I will define on the arrays function, and then my test will run in some specific environment, and I'm okay then to test the actual functionality of the function being tested, not its dependencies. Following on, I need also to start and replace all the dependencies of the buy stock function. We replaced the user data provider. We need also to replace the tax calculator. But also we have a problem here. So the tax calculator is a static function. The calculate tax is a static decimal calculate tax, so it's not possible to create an instance of that tax calculator with that function because it is static. And this is a small highlighting saying that static functions are hard to test. So if you can avoid static functions all the time, you can avoid them. And in most situations you end up refactoring the static functions into non-static in order to be able to test them. So we're gonna edit the tax calculator and do it non-static. And I'm heading back to my function being tested, and time also to create the mock of the tax calculator. Tax calculator mock equals new mock I tax calculator. And what I can do here, also I can set up the tax calculator to have a specific behavior. And I'm gonna say tax calculator setup. This is the mock I want to set up. Calculate tax. I don't care for the amount of money being calculated. I don't care about the user. I just want some predictable results from this function. So I'm gonna again define that I want any type of decimal and any type of string as a username. Now, to explain here a little bit the situation, I could, let's say, do the setup and calculate the calculate tax not for any type of string as a username, but only for my username, for example. What would that do is that every time this function, if this function is called with that specific username, it will behave on the setup I defined here. If it's another username or any other username, I can define different behavior, and that it is helpful for a more complex situation. But for now, I just want to return a simple amount of money as a tax on every situation. And following on, I can pass also my tax calculator as a dependency to the stock handler. Now I'm not going to again debug this code. We did it previously. Right now the tax calculator over here, anytime it runs, it will return 20, the same amount I defined on the setup function. So let's tidy up a little bit those parameters in order to have a good visibility of the situation that the test runs. So the amount that I'm trying to buy is let's say 100. Always the calculated tax will be 20. I just take that variable here and place it on the setup of the calculation of the tax, and the balance of the user will always be 100. So balance equals 100, and I now know the exactly the situation that the test will run. So the user will have always 100 balance. The amount I'm trying to place is 20 and 80, sorry, and the calculated tax is 20. That should be equally the amount I'm trying to place, and it should pass eventually. And if I try to run the test with less balance, let's say 50, then the test I'm expecting to fail. So testing failure and success in some situations you can test it on the same test, but it's better practice to test the, let's say, the happy path and the non-happy path on different tests. So let's revert back on the happy path that the test should pass, and I'm running the test. Forgot to, let's say, enter the username over here. So the username is being passed as parameter, and now I'm free to decide whatever I want as a username. We don't care right now. So our system is dependent from the user service. It can run with any kind of username being passed. So let's say now we can run our unit test without any dependencies on the system, right? Well, almost. We got the stock ID remaining, and if I try and change the stock ID over here, pretty much I'm gonna get an exception because that specific stock ID is not on the system. So I need to get back also and remove that dependency from my function. Let's get back to the stock purchase handler, and this is our dependency remaining. It's the stock market service, and it has a dependency to the stock ID. I need also to replace that with an interface. I'm gonna come back here and extract the interface. Pretty basic code for our template, and we extract the interface. I'm gonna get back to the purchase handler. Right now it is a dependency on the class stock market service. I need to add that also as a constructor parameter. Okay, IntelliSense doesn't help you right now, so I will do it. Okay, thank you. And I can remove the service instantiation within the class. So right now all the dependencies are provided externally, and we are also now able to mock the, not the user data provider, the stock market service for that. I'm gonna head back to my test, and of course we have an error over here. We need to pass a new instance of the stock market service, and again we're gonna use mock or however you call it, I stock market service. And now we just need to pass that dependency within the constructor. We don't require any setup from this function because it just throws an error inside. We don't expect something from this service. We just want a dummy object that it will not crash whatever the parameter it is. So of course I need to get back to my code and also edit the function within the controller over here, and I say new stock market service. And this is the point I made also previously on the slides, that testable code requires time and it is hard. So if you've seen the code initially, it was like half of the lines of code we wrote right now. It's easy to write untestable code, it's much harder to write testable code. Okay, I provided the dependency right here, and I think I'm able to run my test right now. And again we're back cool. So the stock ID is 6. I can now provide whatever stock ID I want. It can be something like that. Our system right now doesn't have any dependency at all. Not doesn't have a dependency, but we can control all the dependencies of the function we're testing. So the purchase handler right now gets all the provided services externally. They are mocked by the mock framework. I control what their behavior will be all the time, and now I have a very good base to start writing more tests with many more situations. Right now it is as easy as altering those parameters right here and pressing those buttons. And I guess this is it for now. You can see a more complete example at GitHub. I have uploaded the code from this presentation over there. I have also added some extra functionality with more tests, more code coverage, so you can play around with that code, and also you can switch back to the non-testable stage of the code on another branch and try it yourself. Thank you.